All right, so now we need to introduce friction into this situation. And your first thought should be whichever way it's trying to accelerate, trying to move, friction is going to be working against you. It's going to try to accelerate in this way, which we found because we got a negative acceleration. And remember, we chose this way as positive and this way is negative, or rather to the right is positive and to the left is negative. Now, if it's trying to accelerate in this negative direction and friction is trying to work against it, that means friction is going to be working against it, pushing down the hill. So now we need to figure out what this external force is. Using the equation, force of friction equals the coefficient of friction times the normal force. We know the coefficient of friction in this situation is 0.5, but we don't know the normal force. And that's where that free body diagram where we drew all of our forces before comes in handy. We know it's not going to accelerate up into the sky or down through the slope, so we know our vertical forces on the 12 kilogram mass have to be balanced, which means the normal force has to be perfectly balanced by the y component of the force of gravity. And remember from before that the y component is Fg cosine theta. In this case, it's 90.6 newtons. And if that y component is 90.6 newtons down, then the normal force needs to perfectly balance it and be 90.6 newtons up. And once you have that normal force, you can plug it directly into the force of friction equation, and then you get 0.5 equals, or times 90.6 newtons will be your force of friction. So we're going to find that the force of friction equals 45.3 newtons. Now, this is starting to turn into a mess, but fortunately we have our system equation up here, our system diagram. So I'm going to add that force of friction there. And from there we can get a new net force for the system equation, which is following the exact same steps as before. So I encourage you to pause the video here, see if you can work through it, calculate the acceleration, and then unpause it and see how you did. So let's work through our net force equation for this system. Net force of the system equals mass of the system times acceleration. So we have Fgx and Ff are positive, Fgx plus Ff, and then we have plus Ft and minus Ft, so we can ignore our tensions because they're going to subtract each other out, and subtract the force of gravity of object A. And that's equal to the mass of the system, which again is going to be 12 plus 24, which is going to give us 36 kilograms, times the acceleration. Fgx we already found to be 78.7 newtons, plus the force of friction, which we just found to be 45.3 newtons, minus the force of gravity of A, which is still 240 newtons, and that's equal to 36 kilograms times the acceleration. We can combine these three into 116 newtons. Have to be very careful about your positives and negatives, and that's equal to 36 times the acceleration. Divide both sides by 36, and we're going to get negative 3.2 meters per second squared. Because this is negative 116. Negative 116. And that's your acceleration. Good.